Okay, so hello and welcome to this little quick start tutorial about neo4j, the graph database. The databases that you're probably used to are maybe relational databases, and they have a different concept. Relational databases store their data in tables and rows and columns, and neo4j stores its data in so-called nodes that have properties, and those nodes have relationships between them. The usual relational databases use a query language called SQL, and neo4j of course uses a different query language that's called Cypher. So neo4j also belongs to a group called the NoSQL databases. In this group, you'll also find databases like key value stores that just, like the name says, store a key and a value for that key, like Redis, for example. And there are also graph databases in that group, like neo4j. All right, you can find the documentation for the Cypher query language online under neo4j.com/developer/Cypher. There's the whole documentation, so if you want to dive deeper into Cypher after this video, you'll find all the information there. For this video, we'll use a sandbox provided by neo4j. So just go to sandbox.neo4j.com. If you don't want to use the sandbox on the internet, on the neo4j server, you can just create that as a Docker container on your own machine. I'll show you in a different video how you can quickly set up a Docker container running neo4j. So just go to that video and then come back here to the part where we use the Cypher query language to put in some data and query some data. All right, so just go to sandbox.neo4j.com. You might have to sign up. I've already signed up, so I'll just use my Google credentials to log in here. Okay, so when you've logged in, you'll go to that, or you'll start at this start page that already provides a couple of different templates, let's say, for you that already have data, like the movie database, crime investigation database, whatnot. So later on, you can use a couple of those prepared databases to play around with the query language Cypher and get used to neo4j and the browser. For this tutorial, we'll create a blank sandbox that does not have any data in it, and just create all of the data ourselves. Now this will create a database that we'll use, and if you use this sandbox, this will expire in about 3 days, so all your data will be gone after 3 days. What you can do is you can extend that period one time for 7 days, so you'll have 10 days after this period. Your data will definitely be gone. To extend that, you have to put in some data, but we won't do that for now, because for this tutorial, 3 days is more than enough. We'll just open it. This will take some time. I'll speed up the video and we'll see us when the browser has come up. All right, now the browser has come up. We're already connected to the database as neo4j. We don't need a password in this case or anything. We're already connected. Up here you have the prompt where you can put in your query language commands. So we're good to go. So in Cypher, to create something, we use the keyword create, or the command create. We can create nodes or relationships with create. Now we'll start with a column. I'll explain why later. And then create a node with a certain type. The type that we specify here after the column is song. So we'll put in songs into our database. And then we can set properties for this node of the type song. So a song, of course, have a name. The name in this case will be Pigs on the Wing 1. So you might already guess that we're talking about Pink Floyd here. And another property that we use is length of the song. And this song is 125 long. All right. So this would be already a query that we can send off and create a node. We would be good to go. But there's some important things to note here. Well, first of all, neo4j is a schemaless database. So you might have noted that we did not set up a schema. We did not say the type of song has properties called name and length. So we can put in here whatever we want. We could create another song that has title instead of name and doesn't have a length and whatever. So we're not really locked to a specific schema. Of course, you should keep a schema in mind because if you name one song with the property name and another has a property called title, that will be hard to query. So properties that have the same meaning should of course also have the same property name. So we'll always use property name for name of the song. The next important thing is that are the data types that we're using here. These two data types are strings, so text that we put in here. This might make it hard to work with length. So if we want to compare the length of different songs or maybe add the length of different songs up so that we know how long the whole release takes or whatever, it's hard to do that with string. So we want to convert that to a data type that's more useful for that. Now, neo4j provides you with a couple of data types like integer, float, string, boolean, date, and time, and so on. So what we'll use for this property here is, of course, a time data type, and we can just convert that with a function called time. Put the string inside the function, and this function will convert this string here to a data type called time, and then we can work with certain functions later on that are specific to time. Now the next thing to note, I told you about the colon up in front. We can do rather complex queries over more lines, and if we want to reference to this node that we created here later in the query, then we'll have to give this sort of an alias or a name or a variable name. So we'll just call that pigs1. So this is just the name that refers to the object that is, or the node that is created in here. This name or alias is only valid within the query. So after we send off the query, this name will be gone. We can't reference it anymore. It has no relation whatsoever to the properties in here. So it's really just temporary. All right, so again, we could send off this query and that would create the node. But we can also push Shift and Enter here and enter a new line. So this is still the same query, just a different line. And we can have a couple of create statements in one query. So I'll just copy and paste the rest of the songs in here. All the songs have the same format, or all the statements have the same format. We'll use different aliases, of course, for the different songs in here. And now we've created or prepared the creation of all the songs. Next, what we want to do is we want to create the recording. Again, we'll give it an alias. That's the same as the name of the record. And then we'll call this a release. This could be a CD or could be a vinyl record or whatever, and give it a name. Again, this is of course called animals, and another property called year, which is the year of the release, which is 1977. All right, so now we've created all the nodes for the songs. So by the way, this data type would be, I think, float or integer. I'm not sure what the default is, but we don't have to specify that here. So there's some sort of auto detection going on. So we don't need to do anything specific here to make this something called a number. This is a virtual data type called a number. And neo4j will do what's necessary in the background there. All right, so we've created all the nodes. Now we want to create a relationship between those nodes. Again, we will create something. And now you already see that we get a proposal here to use those aliases that we used up there. So we'll just use pigs1 as the alias for the first song, and then we'll start to draw sort of an arrow. So we'll say dash. Then to specify the relationship, we'll use those brackets here, and then we'll finish the arrow by using dash and greater than. This will convert the arrow to this arrow symbol, and then we'll just use the alias for the record in here. So this is sort of the template to create a relationship. Now, of course, we also have to give the relationship a type. Again, we start with colon. We can also give this relationship an alias, but we don't need to because we won't use that in the same query afterwards. And then we give the relationship a type. All right, so as this is an arrow, as you can see, relationships can have a direction. They can be, they can point in one direction. So in this case, from song to release, and then it makes sense to give it a name that reflects the direction of the relationship. So song appears on release. This just makes it easier. You can name it however you want, but it makes it easier in everyday life to sort of remember what the direction is and how to use all that. Now, the specific thing for neo4j or graph databases is that you can also assign properties to relationships. Now, in relational databases, if you have a foreign key relation between two tables, you cannot assign any properties to that relation. You'd have to set up a translation table between them, and you can't use, like the normal relationship in relational databases. In graph databases, this is possible. So we can give this a property called song number and say pigs has a relationship appears on the record or the release animals, and the relationship has the property song number 1. All right. Again, we would be good to go to send that off. But of course, we also want to link the other songs to this release. Let's just copy and paste that. Now, this is the first complete query where we reuse all the aliases, and with this play button here, we can send that off. We don't get an error message. So what we see here is everything works fine. And now we can click on database information here, and we'll see that we have a couple of buttons here. We see that with this asterisk, this selects for everything, for every node. You see the node types that we've defined, and you see the relationship types that we've already defined. So let's click on the asterisk here and see everything that we've just created. All right, and what we see here, oh no, we forgot to link this one song to the release called Animals. Okay, so we want to do that. But first of all, before we connect this little dangling song here to the node, I'll just show you what you can do with this display. If you hover over one of the nodes, then in the lower left corner down here, you'll see the properties of the node. So there's always an ID for the node that has been auto-assigned by the database for you, and then you see the length property and you see the name property down there. Now, name property is a special property if you use this browser, because if the node has a property that's called name, this will be displayed in the node here as the, let's say, title or description for the node. If you don't have a property called name, I think it will show the idea. So that makes it easier to read. If you sort of use this display that you have a name, that will be displayed for the node in here. Yeah, you can move this stuff around however you want. But what we want to do now is we want to connect this node to the release. So again, or in this case, I'll show you a different type of command. So we'll use the match command. Again, we can say the syntax is quite similar to the create statement. We can say we want to match a song. And then again, in curly brackets, we can specify sort of filtering criteria for the node we want, or the nodes we want to match. In this case, we'll say, like this dangling thing here has the name Pigs on the Wing 2. So this will be our filter criteria. And as all the names that we have in the database right now are unique, this is enough to match exactly this one node that we want to relate to the release. Now again, what we want to do is we want to give this thing an alias. So let's just name that S for song. And then another match command for the release. And again, the filter will be the name. Of course, this is also unique within the database, so we'll just get back one node. So now we've sort of selected the song and the release with those match statements, and we can reuse that in another create statement. So we say we want to create a link or a relationship from the song. Again, dash greater than to the release. All right, so this is pretty much the same as before. Again, we want to use appears on as the type of the relationship, and then give a property to the relationship that's called song number, and this is song number 5. All right, so this is how you can create relationships between existing objects. Just match to the objects that you want to create relationships for, and then create the relationship like this. We'll send that off. Again, no error message, so everything seems to have gone fine. And then if we select everything again over here, we'll see that Pigs on the Wing 2 now is attached to the release and doesn't come off, however hard you pull it. So this worked. Okay, another neat thing is you can also set up everything in one command. So if we have a release that only has one song on it, we can set that up in one command. Now there's a band called Meshuggah. They have a release that has only one song that's called I, and we'll just create that in one statement. So again, we'll say S for the song. Then we'll give them the song the property name. The name is I. The length of the song, again, we'll convert that to a time, is 21:04. All right, so that's that. We've created, or this creates the song. then this appears on as song number 1. On a release, and the release also has a name. The name is I as well, and the year of the release is 2004. All right, so this would create the song, the release, and the relation between them. Now what we can also do is we can return what we've just created, and then again just specify the aliases. So we'll return the song, I forgot the alias here for the relationship, so let's give it an alias R for relationship, and I used R for release, so it's A for the relationship appears on, R is for release. It doesn't matter which sequence you have in here, you just want to return everything, and then just say A for the relationship, and then send that off. So you see it gets created, no errors here, and it will return what we've just created in that same statement. So we see what we've just created, and then again if we select everything, now you see everything that we've just created, and you see that this couple here does have no relation whatsoever to the recording or the release animals, as it should be. It's its own thing. Right, so that's how you create data in neo4j. Now, another thing that I want to show you is how you can delete stuff. Again, if we want to delete everything, we can use the match query to match everything that we want to delete. I can't write match. All right, so we'll again use S and song for the song that we want to match. We want to match every song that has a relationship. The relationship of type appears on, and then we'll also match to a release or any release. So if we don't specify any other properties that we want to filter for, then of course the match will match every song and every release and all those pairs that have a relationship that has the type appears on. Right, so like dangling songs that would have no relationship or whatsoever wouldn't be selected. And then we just say delete everything, delete the song, delete the relationship, and delete the release. Send that off. Again, no error message, and you can see everything here has disappeared. So we see that there's nothing more in our database. We've just deleted everything. All right, so much for the quick start. You can, of course, before you delete everything, play around with the data or use some of the prepared data sets. Let me know if you want me to cover something else concerning neo4j in the comments down below. And yeah, hope to see you in another video.